This lesson is going to go over what is a rational number. And often in math notation, it's represented by the letter Q, which I know doesn't make a lot of sense, but the letter R was already taken. So they represent it as Q. So a rational number is any number that can be written as a fraction with whole numbers, either negative or positive, on the top and the bottom of the fraction. So some examples, well, there's tons of examples. A lot more numbers that we work with are rational number than irrational. So 3, 2.5, negative 17.47. These are rational numbers, but there's also a lot of other rational numbers. We said that it was any number that could be written as fractions, so fractions are obviously rational numbers. Fractions with negatives in them. Okay, these are all rational numbers. You might ask why these other ones, decimals, are. Well, 2.5 can be written as 2.5, so that can be written as a fraction. So can this one, negative 17 and 47 over 100. So you can write that as a fraction. Okay, so some that are not examples are ones like pi and also the square root of 2. Numbers like this. So are whole numbers rational? Well, yeah, whole numbers are, because the number 4 could be written as a fraction, 4 over 1. So all whole numbers are. Are integers negatives and positives? Yeah. Negative 5 can also be written as negative 5 over 1. Doesn't change it. So it can be written as a fraction. What about repeating decimals? Okay, so 0.333 repeating. Well, this is actually a rational number because that is equivalent to 2/3. Okay, so all repeating decimals actually match up with a fraction, so they are rational. Okay, now, what are not rational are decimals that are non-repeating and they don't end, non-ending decimals. These are not rational. Okay, so that's why pi, which is approximately 3.1415, does not repeat, does not end. That's why that's an irrational number. Okay, the square root of 2 also does not repeat and does not end. So it's called an irrational number. Okay, so those are some examples. So let's see if we understand. So if you want to try this on your own first, pause the video. You can just write down if you think it's rational or irrational. Okay, so I'm just going to go over these now. So negative 1.53, well, that can be written as a fraction, negative 1 and 53 over 100. So that makes that one rational, or Q. 1.3, well, that's just a decimal that ends, so that could be 1 3/10. So that one's rational. So we'll say that one's also, put a Q beside it. Pi, we already said as an example, was irrational. That one we can represent with an I, because it doesn't end and doesn't repeat. You cannot write it as a fraction. Okay, negative 5 over 2, it's already a fraction with whole numbers on top and bottom, so that one's rational. The square root of 3 does not have an exact answer. It's an estimation, so that one is irrational. The square root of 9 is equal to just 3 wholes, so that one's rational. So we'll say that one's Q. 0.875, well, you could write it 875 over 1,000, so that one's rational. 6 over 7, that one is a fraction, so that's rational. The square root of 8, is actually irrational because you can't have an exact answer for that square root. It's a non-repeating, non-ending decimal. And 7 is just a whole number, so it is rational. So those are some more examples. So you can order these ones as either irrational or rational. Give them a try. So you can pause the video again and try it yourself. All right, I will write the answers to these quick. We already said pi was irrational. This one is rational. This one's also rational. This one's a repeating decimal, but it is still rational because that would equal 4 2/3. Okay, this one's rational. This one's a fraction, so it's rational. Square root of 64 is just 8, so that's rational. Square root of 3 does not have an exact answer, so it is irrational. Okay. And here's one question from a former Pat that you can try. So you can pause it and give it a shot, see if you can answer it.